My dear students, in this video, in the topic linear programming, I am going to solve that type problem, that is type 3 transportation problem. That is, there are two types of factors P and Q. A certain commodity can be transported from the factories P and Q to the depot A, B and C. The capacity of the factory P and Q are 8 units and 6 units of commodities. And the weekly requirement commodities of the depots are 5 units, 5 units and 4 units of the depot A, B, C respectively. The cost of transportation from the factories to the depots are given in the table. That is, cost per unit in rupees from the factory P to the depot A is 160 rupees, factory P to the depot B is 100 rupees, factory P to the depot C is 150 rupees. Similarly, the transportation charges from Q to depot A is 100 rupees, Q to depot B is 120 and factory Q to depot C is 100 rupees. So using this data, we have to find out the minimum transportation cost from the factories to the depots and what are the required commodities for the minimum transportation. See, the constraints are since X units and Y units of the commodities are transported from the factory P to the depot A and B respectively. Therefore, the constraints are X greater than or equal to 0, the constraints are X greater than or equal to 0 and Y greater than or equal to 0. This is the first constraint. Both X and Y are positive. The X commodities are transported from the factory P to the depot A and Y commodities are transported from the factory P to the depot B. So naturally, the remaining 8 minus of X plus Y commodities are transported from the factory P to the depot C. Since X and Y are transported from P to A and B, therefore the required commodity transported from the factory P to the depot C, 8 is the total unit in the factory P, therefore 8 minus of this X plus Y is a required commodity transported from the factory P to the depot C. Similarly, the cost P to the depot A is 160, P to the depot B is 100, P to the depot C is 150 rupees per unit. Similarly, Q to the depot A is 100, Q to the depot B is 120 and Q to the depot C is 100. Similarly, since the capacity of the depot A is 5 units, the X units are transported from the factory P, therefore remaining 5 minus X units are transported from the factory Q to the depot A. Since the depot A is of capacity 5 units, the X units transported from P, therefore the remaining 5 minus X units are transported from Q. Similarly, Y units of commodity transported from P to B, the remaining 5 minus Y units are transported from Q because the capacity of B is also 5 units. So remaining 5 minus Y units is transported from Q to the depot B. Okay. So as that 5 minus X from depot Q to A and 5 minus Y units from depot Q to B, factory Q to B, therefore the remaining, since the capacity of the factory is 6 units, the 6 minus of 5 minus X plus 5 minus Y units are transported from the factory Q to the depot C. So total 6 units of the capacity of the factory P, therefore 6 minus of 5 minus X transported to A, 5 minus Y transported to B, these two 5 minus X plus 5 minus Y minus of 5 minus X plus 5 minus Y is the required commodity transported from the factory Q to the depot C. So So the constraints are x minus y greater than or equal to 0. Here 8 minus of x plus y is greater than or equal to 0 because it is positive. Since all the equations are positive, 8 minus of x plus y greater than or equal to 0. So simplifying you will get x plus y. You can take that outside. X plus y is less than or equal to 8. This is constraint 2. Similarly, 5 minus x is the units of commodity transported from Q to the depot A. Therefore, 5 minus x is greater than or equal to 0. Therefore, x is less than or equal to 5. This is equation 3. And 5 minus y is the commodity transported from the factory Q to the depot B. Therefore, 5 minus y is greater than or equal to 0. Therefore, y is less than or equal to 5. This is equation 4. Similarly, 6 minus of 5 minus x plus 5 minus y is transported from the factory Q to the depot C. This is on simplification. You get, if you bring to the minus inside, this is minus of minus plus x plus y minus and plus 5 plus 5 10. 6 minus 10 is minus 4. So x plus y minus 4 is greater than or equal to 0. This is our fifth constraint. X plus y minus 4 is greater than or equal to 0, or x plus y is x plus y is less than or equal to 4. Minus x, your equation is x plus y less than or equal to 8, okay. See, x plus y, here is some small correction. X plus y minus 4 is greater than or 0. This implies x plus y is greater than or equal to 4. If you bring this 4 to that side, the inequality remains same. X plus y is greater than or equal to 4. This minus 4 becomes to the right hand side. X plus y is greater than or equal to 4. This is equation 5. Okay. These are the 5 constraints for this problem. X and y are positive, non-negative variables, and 8 minus of x plus y greater than or equal to 0 implies x plus y is less than or equal to 8, and 5 minus x greater than or equal to 0 implies x is less than or equal to 5, y is less than or equal to 5, and x plus y minus 4 is greater than or equal to 0 implies x plus y is greater than or equal to 4. Greater than or equal to 4. These are the 5 constraints for this problem. So we have to find out the minimum cost for transportation of the commodities from the factories P and Q. What is the minimum cost and how much commodities should be transported from the depot A, B and C. So first x greater than 0 and y greater than equal to 0 is x axis and y axis. This is x greater than equal to 0, y greater than equal to 0, this is x greater than equal to 0. X plus y, see, x plus y equal to 8. For this graph, x plus y equal to 8. If x equal to 0, if x equal to 0, y equal to 8. Similarly, if y equal to 0, x equal to 8. So this is the graph. What is the graph is? 0, 8, 8, 0. 0, 8, x0, y8, this point. Here, y8, x0, y8, x0, x0, y8, this is the point 0, 8. This is the point 0, 8, x0, 8, and y0, x8, y0, x8. This is the point, what is that? 8, 0. So joining these 2 points, you will get the line x plus y equal to 8. Okay. So this is the line x plus y equal to 8. First, x greater than 0, x greater than equal to 0 is y axis, y greater than 0 is x axis, and x plus y equal to 8 is the line we have drawn. And third constraint, x less than equal to 5, that means x equal to 5. X equal to 5 is, this is x equal to 5. In between 4 and 6, you get x equal to 5. A line drawn parallel to y axis is x equal to 5. This is x equal to 5. This is third constraint. Fourth one is y less than or equal to 5, that is y equal to 5. Y equal to 5 is the line drawn at y equal to 5 parallel to x axis. Similarly, here in between 4 and 6, we will get 5. Y equal to 5 is the line drawn parallel to x axis. This is y equal to 5. Okay. Fourth one is over. And fifth one, x plus y equal to 4. X plus y equal to 4. If x equal to 0, y equal to 4. If y equal to 0, x equal to 4. If x is 0, y equal to 4. If y is 0, x equal to 4. That is 4 comma 4, 0 comma 4, 4 comma 0. This is a line joining 2 points will get x plus y equal to 4. 0 comma 4, x 0, y 4, x 4, y 0. Joining these 2 points, we will get x plus y equal to 4. Super. This is x plus y equal to 4. We have drawn all the constraints. The region x plus y greater than or equal to 4 is this area. Greater than or equal to 4 is away from the origin. This is greater than or equal to 4. X plus y greater than or equal to 4 is this region, and x plus y less than or equal to 8. X plus y, this is x equal to x plus y equal to 8, less than or equal to means towards the origin, this side. So this is the bounded region, feasible region for the solution. In between these 5 constraints is the required feasible region. X plus y greater than or equal to 4 is away from the origin, and x plus y equal to 8, less than or equal to 8 is towards the origin. So these are the feasible region, bounded region, and every point in this region is the solution part of the linear programming. So the corner points are the bounded region. This is the point x0, y4, x0, y4, and this is again x0, y5. So the corner points are, you consider this is by A, 0 comma 4, this is B, 0 comma 5, and this is the point intersecting the line x plus y equal to 8 and y equal to 5. This point is y equal to 5. and also is 8. X equal to what? Y equal to 5. You substitute x plus y equal to 8, y equal to 5 means 8 minus 5, 3, x equal to 3. So 3, 5 is another corner point A, B, C. See, this is the corner point C. And this point, again a bounded region, having the corner point D. This is also the line joining x equal to 5, x equal to 5 and y equal to x plus y equal to 8. In this, if you put x equal to 5, y equal to 3. See, this is 5, 3 is D. In this line, x equal to 5, y equal to 3. In this line, y equal to 5, x equal to 3. So the corner point D has the coordinates 5, 3, and this is the point E. E is x5, y0. Similarly, this is the corner point F. This F is x4, y0. So A, B, C, D, E, F are the corner points of the bounded region. In this bounded region, you have to find out the solution for the minimum cost. So equation of the minimum cost is that if you have to find out now. After finding the graph, you have to find out the minimum cost. I am going to erase here. This table we don't want now. And constraints also. Since we have drawn the graph, we can erase this constraints also. Okay. Now I want the equation of the bounded region. So minimum cost for the commodities transportation, minimum cost for the transportation is to find the cost of the region, cost of the function. Minimum cost is that equal to, we have to add all these things, x into 160, because x commodities transported the cost of 160 rupees, therefore you will first write 160x plus 100y. 160x plus 100y. Similarly, plus 100 into 5 minus x. Plus 100 into 5 minus x. Plus 120 into 5 minus y. This is the objective function. Is that equal to 120x plus 160x plus 100y plus 100 into 5 minus x plus 120 into 5 minus y and plus 150 into 8 minus of x plus y. Plus 150 into 8 minus of x plus y and 100 into x plus y minus 4 plus 100 into x plus y minus 4. This is the required function. 160 into x plus 100 into y plus 100 into 5 minus x plus 120 into 5 minus y. 100 into x plus y minus 4 plus 150 into 8 minus x plus y. See, this is the required minimum cost function. So simplification of this equation, you have to simplify. For that you consider in all the values are multiples of 10. Therefore you can take 10 as a common multiple outside. You will get, if you take 10 outside, you get 16x. Similarly, plus 10y. Here, if you take 10 into 100, 10 into 5, 10 5s are 50 minus 10x. Similarly, if you take 10 outside, 12 you get only 12 5s are 60 minus 12 into y minus 12y. Similarly, 150 out of 150, if you take 10 outside, you will get 15 into 8, 120 minus 15 into x, 15x minus 15x plus into minus 15y. Similarly, plus 100, if you take 10 outside, you will get 10 only. 10 into x, 10x plus 10 into y, 10y minus 10 into 4, 40. You simplify again, you will get the minimum cost function Z. What is that? On simplification, you will get Z equal to 10 into 16x minus 10x. You will get 6x. 16 minus 10, 6x. 16 minus 10, 6x plus 10, 16. 6x plus 10x, 16x minus 15x, x only. 16 plus 10, 26 minus 25, minus 10 minus 15 minus 26, 26x minus 25x is x. Similarly, y, 10y minus 12y, you will get minus 2y, minus 2 minus 15 minus 17y plus 10y is minus 7y. X minus 7y you will get, and the constant terms you will get. What is that? What are they? 50, 60, 110, 110, 110, okay, minus 40. What do you get? 70. 70 plus 120, 190. So 10 into x minus 700 plus 190 is the minimum cost of the function Z. So using this function, we have to find out the minimum cost at the corner points. We have 6 corner points. Okay. Now I am going to erase this diagram. At the corner points, I am going to substitute the values and I will get the Z value. Then only I will get the minimum cost. We will see one by one. So corner points are corner points and minimum cost. Cost, not only minimum cost, cost is it. Cost of the function is it. Corner point A is 0,4 and B 0,5, C 3,5, D 5,3, E 5,0, F 4,0. At this corner point, we have to find out, substituting in this equation Z, in the equation I. First, we have to find out, substitute 0, x equal to 0, y equal to 4. If you put x equal to 0, it becomes 0, y equal to 4. 7 4s are 28. 190 minus 28. 190 minus 28 is 162. 162 into 10. 1,620 rupees. Cost is 1,620 rupees. And x equal to 0, y equal to 5. X equal to 0, y equal to 5. 7 5s are 35. 190 minus 35 is 155 plus into 10. 1,550. Similarly, C 3,5. X equal to 3, y equal to 5. 7 5s are 35 minus 3. 35 minus 3 is minus 32. 190 minus 32. 190 minus 32 is 158 into 10, 1580 rupees. Similarly, D, x equal to 5, y equal to 3, 7 3s are 21. 21 minus 5, 16. 190 minus 16 is 174 into 10, 1740. And x is 5, y equal to 0. X is 5, y equal to 0. 190 plus 5, 195 into 10, 1950. And corner point D, 4 comma 0. X equal to 4, y equal to 0. 190 plus 4 is 194 into 10, 1940. What do you get the minimum cost here? So minimum cost is this. This is your minimum cost. 1550 is the minimum cost on transportation of 0 units of x units and y units, 5 units of y gives you the minimum cost. X is 0, y equal to 5, you substitute in the commodities transported from P. In the diagram, you know, from P, x units, y units, and 8 minus of x plus y units to the 8 minus of x plus y units to the depot A, B and C we have transported. X units is 0. X is 0. Y is 5. So 8 minus from C, 8 minus of x plus y. X plus y is 0 plus 5. 8 minus 5 is 3. So from the factory P, 0 units of commodities can be transported to the depot A and 5 units of commodity transported from the factory P to the depot B, and 3 units of commodities can be transported from the factory P to the depot C. This is one solution. Similarly, another solution, from the factory Q, you transported 5 minus x to the factory A. 5 minus x. X is 0. 5 minus 0 is 5 units only. And Q, 5 minus y. 5 is y, x is 0, y is 5. 5 minus 5 is 0 unit. And this is x plus y minus 4. From the factory, x plus y minus 4. X is 0 plus 5. 0 plus 5, y is 5. 0 plus 5 minus 4. 5 minus 4 is 1. So 5 units from factory Q to the depot A and 0 units from the factory Q to the depot B and 1 unit from the factory Q to the depot C. These are the transportation commodities values. Such values gives you the minimum cost of the transportation, whereas 1550 rupees. So the transportation is minimum. The cost of the transportation, minimum cost of the transportation is minimum cost of transportation. Minimum cost of transportation is rupees 1550 from the factory P, from P to 0 units, 5 units and 3 units to the depot A, B and C respectively. Similarly, from factory Q, 501 units then from factory Q, from factory P, 053 units, from factory Q, 501 units to the depot A, B and C respectively. This is the solution. From factory P to A, B, C depots are units are 0, 5, 3 units, and similarly from the factory Q to the depots A, B, C are 5 units, 0 units, 1 unit respectively, so that the cost price minimum, which is 1550 rupees. That's all about the problem. Okay, this is a transportation problem in the topic linear programming. It's an easy problem, but so that you have to understand very well, then only the problem is very easy. Nothing is wrong, difficult in this problem. You just understand the problem and what is given and what they are asking. That's all about the problem. Thank you.